I am Chamani from Science 2. Today I will present Chapter 8 Mathematical Modeling. What is mathematical modeling? Mathematical modeling is the process of constructing mathematical models. In mathematical modeling, a real-world problem will be translated into a mathematical problem. We then solve the mathematical problem and interpret its solution in terms of real-world problem. Here are some examples of real-world problems. What is the effect of rising sea levels on the coastal regions of Malaysia? How much will it cost to go to college or university in 10 years? And so on. What is mathematical model? A mathematical model is the mathematical relation that describes the real-world situation. In mathematical modeling, a mathematical model is a representation of a system or scenario that is used to gain qualitative and/or quantitative understanding of some real-world problems and to predict future behavior. For example, the simple interest formula I equal to PRT is the relation between simple interest and the other three quantities, that is, principal, interest rate, and time. Here is the one example that can use mathematical modeling to solve it. How long does it take to clean up an oil spill in the ocean? This question is an open-ended question and we do not have enough information to answer it. In addition, this question is also a real-world problem. We usually do not have complete information when trying to solve real-world problems. These real-world problems demand us to use both mathematics knowledge and creativity to solve it. In this case, mathematical modeling is perfect for solving such open-ended questions. There are a few important components in mathematical modeling. First, identifying and defining the problems. Second, making assumptions and identifying the variables. The third, applying mathematics to solve problems. The fourth, verifying and interpreting solutions in the context of the problem. The second last one, refining the mathematical model. And the last one, reporting the findings. Use two examples to show how the mathematical modeling works to solve the problem. Example 1. The grocery store, which is far from the house, sells a pack of 10 kg rice at a lower price than the one closer to your house. Is it worth the drive for the cheaper deal? From the question we get information. There are two packs of 10 kg rice. One of the pack of 10 kg rice has a lower price, but the store sells it further than house. Another pack of 10 kg rice has a higher price, but the store that sells it closer than house. In this case, we can use mathematical modeling to solve the problem. First, identifying and defining the problems. We need to identify the price of a pack of 10 kg rice and the cost of petrol. We need to determine the distance from the two stores to your house respectively. Then we need to find the information that needed from the internet. For example, the price of a pack of 10 kg rice from each store, the distance from each store from a house, the current petrol price, and the car petrol consumption rate. Second, we need to make some assumptions. We assume that the route between the house store A and store B is a perfect straight line. The person who need to buy a pack of 10 kg rice driving car to the store and purchasing the same number and brand of rice as store A and store B. The third part, we need to identifying the variables. In this part, we need to use some symbol or alphabet to represent the variables in the question. Let S represent the distance between store A and store B. P1 and P2 represent the price of a pair of 10 kg rice at store A and store B respectively. M represents the petrol consumption rate of the car in km per liter. N represents the number of packs of 10 kg rice to be purchased. H represents the current petrol price in ringgit per liter. S represents the difference in price in ringgit for purchasing the pair of 10 kg rice at store B as compared to store A. And the last one, T represents the difference in the cost of petrol in ringgit for driving to store B as compared to store A. Part applying the mathematics to solve problems. In this part, we need to do some calculation. The price of a pair of 10 kg rice in store A is 25 ringgit 95 cents, which is P1, and the in store B is 23 ringgit 99 cents, which is P2, and we like the quantity of 10 kg rice to be purchased with 2 bags, which is N. The price to be paid for 2 packs of 10 kg rice is in store A is 51 ringgit 19 cents and in store B is 47 ringgit 98 cents. Therefore, by purchasing the rice at store B, one can save 3 ringgit 92 cents, which is the big as that the distance between store A and store B be 6 km, which the more as the petrol consumption rate of a car be approximately 17.6 km per liter, which is the M. The current petrol price be 2.08 cents per liter, which is the H. The petrol needed for the 6 km route equal to 0.341 liter. Cost of petrol for the 12 km for two-way route equal to 3.42 cents, which is the T. Therefore, we save 2.15 cents by purchasing 2 packs of 10 kg rice at store B. Part 4. Verifying and interpreting solutions in the context of the problem. When we verifying and interpreting solutions, we consider are the solutions able to solve the problem? Is it rational to translate the solutions to real-world situations? The resulting mathematical model is as follows: S equal to P1 minus P2 times N, T equal to S over N times H times 2. If S more than T, then E is sensible to drive to store B to purchase rice and save more money. If S less than T, then we should not drive to store B to purchase rice. Example of using the model S equal to P1 minus P2 times H equal to 25.95 minus 23.99 times 2 equal to 392 cents. T equal to S over N times H times 2 equal to 6 over 17.6 times 2.08 times 2 equal to 142 cents. If you forget the alphabet I say, you can see this diagram to refer back what I said just now. Since S more than T, you save more money by purchasing rice at store B, and it is sensible to drive to store B. Thus, the mathematical model is able to solve the problem. From the constructed mathematical model, we can make further exploration. First, if all the variables remain the same, how far can store B be located so that it is an optimum choice? Optimum means that the best of the most profitable. So we use the formula S more than T and substitute the value of each alphabet. So and last the S as an unknown. And then we find the value that S less than 16.6 km. This means that if the distance between the two stores is less than 16.6 km, then it is sensible to drive to store B to purchase rice. second one is the optimum price of a pair of 10 kg rice at Strawberry that will attract a person drive to Strawberry to purchase it. And again, we use as modernity and substitute the value of each alphabet, but this time we use P2 as an unknown and find the value of P2 less than 25 ringgit 24 cents. It means that if the price of a pair of 10 kg rice at Strawberry is less than 25 ringgit 24 cents, then it is worth the trip. Therefore, the above mathematical model allows us to not only answer the question of is it worth it for the given situation, but also allow us to determine other factors that support or oppose the decision to drive further to purchase the rice. The second last part, defining the mathematical model, the assumption made regarding the route between the house door A and store B is a straight line to be revised. If the route between the three places is not a straight line, how does this impair our model? Like this picture, if the route between the three places is a triangle, what changes in our model? So if new assumptions are being made, then the model needs to be revised to reflect these changes. In the last part, we need to report the findings. Use symbols and diagrams when necessary to report the findings. The symbol and diagrams will depict the whole modeling process until it leads to results. Every model has strengths and weaknesses. What is important is that the model identifies those strengths and weaknesses in the report. For example, the value of a person type is not considered in this model. This is one of the weaknesses in the model. If you were driving an extra 12 km for someone to save 2 ringgit 50 cents, according to this model, 75 cents is considered worthwhile. And the second one, the model also did not account for any environmental consideration. Is it environmentally responsible to drive an extra 12 km just to save 2 ringgit 50 cents? This model did not account for environmental efforts such as efforts to reduce carbon emissions. Before example 2, I will explain two functions that apply in mathematical modeling. So the first one is the linear function. A graph resembles a straight line. Like this picture, this line is a linear function with a negative gradient, and this line is a linear function with a positive gradient, and the quadratic function a curved graph in the form of a parabola. Parabola means that the shape of U-shape of N-shape like this picture, like these two pictures, and the curve may rise and then fall or fall and then rise. So in this curve, the curve is fall and then rise, and in this curve is rise and then fall. The last part is exponential functions. A curved graph will illustrating an increase or decrease in values of a data at a sharp rate. The exponential function can be written in the form of equation y equal to cx, where x is a positive real number, a must more than 0, but a not equal to 1, cannot equal to 1, and c is an initial value. For example, c equal to 1 and a equal to 2, graph equal to y equal to 2 power of s is shown as this diagram. And another diagram, it shows the graph of two exponential functions with base e. Example 2, the question is, Amin traveled 405 km on 45 liters of petrol in his car. If Amin wishes to go to a place which is 198 km away by car, how much petrol in liters does he need? Solve this problem through mathematical modeling. So in this case, we need to use 6 important components in mathematical modeling to solve this problem. So again, The first, identifying and defining the problem. We need to determine the volume of petrol required for 198 km, and we need to know that the further we travel, the more petrol we require. Thus, the amount of petrol varies directly with the distance we travel. So the second part, we need to making assumptions and identifying the variables. So first, we need to assume that the driving speed for both 405 km and 198 km routes are the same, and we need to let S represent the distance traveled, Y represents the amount of petrol required, and Y varies directly with X, hence Y equal to Ks, where K is a constant. And the third part, we need to applying mathematics to solve problems. In this part, we need to do calculation and substitute the value again. So the first substitute y equal to 45, which is the amount of petrol required, and s equal to 405 km, and into y equal to ks. So we substitute it and we can get k equal to 1 over 9, therefore y equal to 1 over 9x. This equation describes the relation between the amount of petrol required and distance traveled. So when s equal to 198, we can know that y equal to 22 liters. Hence, 22 liters of petrol is required to travel 198 kilometers. Part 4, verifying and interpreting solutions in the context of the problem. We may not be able to use the linear function model y equal to 1 over 9x in all situations like this graph. For example, if the 405 km route is 2 towns and cities, and the 498 km route is 2 highways, because the car that drives through towns and city will drive in a slower speed, but if it drive in the highway, it will drive in a faster speed. Thus, the car will use up the petrol at a faster rate. The first route, which is a 405 km route, compared to the second route, 198 km route. When this is translated to the real situation, the linear function model content is not suitable to solve this problem. And the second last part, the refining the mathematical model. In this problem, we are not be able to refine the model due to the limited information given. So the last part, reporting the findings. Report the findings of the problem solving based on the interpretation of solution as shown in the presented sections. So last, I will summarize the mathematical model process that we have learned just now. So the first part is identifying and defining the problems, and the second part is making assumptions and identifying the variables, and third part is applying mathematics to solve problems. In this part, we usually do many calculations, and the next part is verifying and interpreting solutions in the context of the problem. Before reporting the findings, we need to define the mathematical model. If yes, then it will repeat by step 1 and continue at this flowing. If no, then you will reporting the findings and the end.
This is all of my presentation. Thank you for watching.